Alright, hello everyone. In this video, we are going to learn how to do an integral. What an integral is, kind of like how a derivative is the tangent line of a function. Let's say you're given a function, you could figure out where it came from, like what's the antiderivative of it, essentially. So the way you would write it out is it's kind of like a large S, and then f of x dx, right? So you're taking the integral of f of x with respect to dx, right? So let's do an example. Let's say you have the integral. Of, let's say, x to the fourth power plus 3x squared plus 4x minus 2 dx, right? So with an integral, you could take each one individually. Kind of like when you take a derivative, you do each one separately. You could do that. So that's what I'm going to do. Until you get more practice, that's what I recommend doing. So we'll do the integral of x to the fourth dx. And then plus the integral. And you see how over here there's a 3x squared? You could take the constant out because it's a constant. And you don't really need it to do an integral. So 3, and then this will be x cubed. Oh, I'm sorry, x squared. X plus, again, take out the constant for x dx. And so now you're probably asking yourself, well, what do I do in this case? Like, do I take it out? Do I leave it? Just take it out, and you're going to just take the integral of dx. And that's probably the easiest integral out of all of them, because the integral of dx is just x, right? But we'll get to that in just a second. So let's start from here. So the way you do an integral with a power, you're gonna kind of similar to the power rule, where you took down the n and then did n minus 1. Well, in this case, you're adding 1. So it's going to be x to the fifth power, right? But this is where it's important. You always divide by that power, right? And so you're probably asking yourself, well, how does that make sense? Well, take the derivative of this. If you take the derivative of this, you should get x to the fourth, right? So 5x to the fourth. That on its own isn't x to the fourth. That's why you have that divide by 5. You divide, and you're left with x to the fourth, right? So always make sure you keep that fraction, all right? Sometimes it will cancel out, which it will happen in the next case, but always make sure you write that out. So now to the next one. So again, you have that constant outside times x cubed over 3. And so this is a case why it's important and why it's always good to write it. These 3's get canceled out, and you're left with x cubed, right? Plus, again, leave it outside, x squared over 2. And again, you could simplify this, and that becomes a 2. And I'll clean this up in just a second, because there's another point I have to make. Minus 2 times the integral of dx is always just x. It's very simple. You could think of it this as a 1 if you want. So what's integral of 1? X, right? And so let's clean this up. You have I like to write the fractions like this just because I feel like it's a bit cleaner and neater. Plus x cubed plus 2x squared minus 2x. And this is the most important part. Always write plus c. So what's the significance of this plus c right here? What's the significance of that? So pretty much when you take the derivative of a function, like over here, let's say we took the derivative of this. So side note, let's do this on the side. All right. So let's say we took the derivative of that. It'd be 4x cubed plus 6x plus 4, right? So what happened to this 2? As a constant, it disappears when you take the derivative. So that assumption always stays when you take the antiderivative. You always assume that there is a constant. It could be 0, 1, a million, a trillion, negative, a quadrillion. It doesn't matter. Always have that plus c. All right? So this is your final answer. It's that easy. That's all you have to do. You just take it one by one, break it down into its steps, take the integral of each one, and then add that plus c. Never forget that plus c. All right?